Hello kids, welcome to ICSE Chemistry Hub. This is a channel which deals with grade 10 ICSE chemistry chapters, and this is the best place for you to score 90 plus. So please do like, share, comment, and without fail, please do subscribe our channel. Also, do suggest this channel for your friends as well as family members. We would also like to thank you, and we would like to tell you that we have hit 100 plus subscribers. I would just want to say a huge thank you to each and every one of you who have supported this channel. Whether you have been here since the beginning or just joined recently, your likes, comments and support means the world to us. So please do continue supporting us, and once again, wholeheartedly, we would like to say a big thank you to all. So children, today we are going to start with the first chapter of grade 10. That is again a very, very important chapter for your board exam, that is dealing with periodic table. This chapter you have already dealt in your 9th standard. Now here in grade 10, we will be dealing with the periodic properties and the variation of properties that you get to see in a period and in a table. Now, please don't miss this chapter, because here we also will be dealing with the most important board questions that are frequently asked from this chapter, that is periodic table. So, without any delay, let's start. So, children, this is what a periodic table looks like. So, the father of periodic table was a Russian scientist. The name of the Russian scientist was Dmitry Mendeleev. So Dmitry Mendeleev is known as the father of the periodic table because he developed a table which he called as the periodic table. It is dependent on a law. Now what is that law called as, children? He named it as Mendeleev's periodic law. He was the first scientist who made an attempt to classify the elements. He placed the elements according to their atomic masses. Now, what do you understand by the word atomic mass, children? Atomic mass means nothing but atomic weight. So, he was the scientist who arranged the elements according to their atomic masses or atomic weight. So, he developed a law which is called as Mendeleev's periodic law. What does Mendeleev's periodic law state? That the properties of the elements are periodic functions of their atomic masses. Okay, so he said that the elements show these properties, and the properties are dependent on their atomic masses, or we can also call them as atomic weights. So he said that whatever properties the element or that particular element is showing, it is because of their atomic masses or atomic weight. Okay, and this was a great help. Till a certain period of time, it was Mendeleev's periodic table that was followed, and he had also left. We have learnt all of this in our grade 9. This is just a sort of revision for you. So he arranged the elements, as we know, according to their atomic masses, and he also left a huge number of gaps. Okay, he said that these elements, these large gaps, he said that these elements are not yet discovered now, but in the coming times, these elements would be discovered. Not just did he leave gaps for these elements, for these undiscovered elements, but he also predicted the properties of those elements, which was a very, very huge discovery at that time. Okay, so this was one of the contributions made by Mendeleev, that he left some gaps in the periodic table, and he was even able to predict the properties. In fact, he was even able to predict their atomic masses. Okay, he said that these masses are not yet discovered now, but when they will be discovered, they will have this particular atomic mass, and this will be the properties of the elements. And he was absolutely right, and most of his predictions came true. Okay, so he believed that atomic masses of certain elements will be the criteria for classifying the elements, and after certain years this concept got changed because of a scientist called as Henry Moseley. So the periodic table, which we call as the modern periodic table, is given by this scientist, which is called as Henry Moseley. Okay, so the modern periodic table is given by the scientist called as Henry Moseley. Now, there was only one small change from Mendeleev's periodic table. I just now told you how did Mendeleev classify the element. He classified the elements based on their atomic masses. That means the atomic weight was the criteria that was followed while Mendeleev was classifying the elements. Okay, but later Henry Moseley said that instead of atomic masses, what criteria should be followed while classifying the elements, children? It should be atomic number. So atomic number was the criteria or is the criteria on which the modern periodic table is based nowadays. Okay. So based on that, he gave the modern periodic law. What is the modern periodic law? State that the properties of the elements same like Mendeleev's periodic table. What does Mendeleev's periodic law state? That the properties of elements are periodic functions of their atomic masses. The same law was put forward but with a different name called as modern periodic law. The law remains the same except that there is a change in one of the word. What does modern periodic law say? That the properties of the elements are periodic functions of their atomic number. Whatever periodicity that they show, whatever repetition these elements show, it is the criteria on which it is based is atomic number. So children, if they ask you what is modern periodic law, you have to say that the properties of elements are periodic functions of their atomic number. So on what criteria are they based? Are they classified, children? They are classified on the criteria of atomic number. Okay. And whenever I say atomic number, it correlates the position of the element, or the position of the element is decided with the help of electronic configuration. Okay. So elements are arranged in increasing order of their atomic number. This is the definition of the periodic table. What is a periodic table, children? A periodic table is a systematic arrangement of elements. Now, how are they arranged? They are arranged in increasing order of their atomic numbers. Clear? Now, in the periodic table, children, as you can see here in this table, children, there are some horizontal lines that are there and there are some vertical lines that are there in the periodic table. Okay, now please remember the short form that I am giving you. HP. Okay, please remember the short form HP. What does it stand for? Horizontal lines in the periodic table. Can you see the horizontal lines, children? This is a horizontal line. This is a horizontal line. This is a horizontal line. So what are the horizontal line in the periodic table called as? Remember the short form as HP. The horizontal lines in the periodic table are called as periods. And can you see these vertical lines here, children? Okay. So the vertical lines here are called as groups. Clear? So I hope the difference between periods and group is clear to you. Okay. What is a period, children? Period is the horizontal lines. Remember the short form HP. The horizontal lines of the periodic table are called as periods. And what are groups, children? The vertical columns in the periodic table are called as groups. Okay. So horizontal lines are called as periods. The vertical lines that are there, okay, the vertical lines are called as groups. Okay. So now here, children, please remember the number. Let us first start counting the horizontal lines. What are the horizontal lines called as, children? The horizontal lines, we know it is HP. The horizontal lines are called as periods. So this is the whole periodic table that is given to you. This is period number 1. Hydrogen, helium belongs to period number 1. This is the second period that you have. This is the third period that you have. So 4, 5, 6, 7. So how many horizontal lines, or in other words, how many periods do you have, children? We have 7 periods in the periodic table. Please remember this number. Okay. It is very clearly shown how many periods are there in the periodic table. We have got 7 periods. Okay. We also know that the vertical lines, okay, the straight lines in the periodic table are called as groups. Let's start counting how many groups are there. Now, group means the vertical lines are called as groups. Okay. So, let's start counting the groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the 13th group. 14, 15, 16, 17, and this is the last group, that is 18. So if you have a look at the periodic table, how many horizontal lines are there, children? Horizontal lines are 7. I hope you are able to see this. And how many groups are there in the periodic table? As you can see the number here, there are 7 periods and there are 18 groups. Okay, so this is all about periods. Now we also need to remember what is the similarity in periods and what is the transition that a period will show. Now what do you understand whenever I say the word period, children? First thing you should understand is what is a period, children? The horizontal lines are called as the periods. Okay. Now please remember the statement that I am giving you. Period number is directly proportional to the shell number. What is the sentence I gave you, children? It tells you that the period number will give you how many shells will be there in that element. Clear? For example, let us look at the first period. Which are the elements that are there in period number 1? Here, where is period number 1, children? It has hydrogen. Hydrogen has atomic number 1. So, how many electrons will be there in hydrogen? 1. Whereas helium has an atomic number of 2. So, how many electrons will it have, children? It will have 2 electrons. So, can you see here, children? Period number is directly proportional to the number of shells. Am I clear? So, if I say it is period number 1, how many shell does hydrogen have? How many shell does helium have? Hydrogen has 1 shell. Helium also has 1 shell. So this is one of the things that you need to remember. Let's once again revise it. What does the period number tell you, children? The period number will tell you how many shells are there in a particular period. For example, if you look at lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, it belongs to period 2. Now we know period number is directly proportional to the number of shells. If you have a look at lithium, lithium is having 2 electrons in the first shell and 1 more electron in the second shell. Similarly, beryllium, 2 here, the atomic number is 4. So the number of electrons that we need to arrange is also 4. Okay, so can you see here, children? How many shells does lithium have? Lithium has 1 shell. This is the second shell. Beryllium has 1 shell. This is the second shell. Okay, boron will again have how many shells, children? It will have 2 shells. Nitrogen will have how many shells? 2 shells. Why 2 shells? Because it belongs to period number 2. So if it is belonging to period 1, it will have 1 shell. If it is belonging to period 2, it will have 2 shells. Can you tell me how many shells will the third period have? The period number is going to tell you the number of shells. So for example, if they ask you, an element X belongs to period number 4. Okay. So the moment you hear period number, just remember this statement. Period number is directly proportional to the number of shells. So can you tell me if the period number is 4, how many shells will be there? The number of shells also will be 4. If it belongs to period 5, how many shells, children? It will have 5 shells. Period number 6, it will have 6 shells. So please remember, the period number is going to give you the number of shells. Clear? Now please look at the statement here, children. Each period begins with an element which is having only 1 electron in the outermost shell, and by the time you reach the end of the period, you will have a fully filled outer shell. Okay, I will just explain this statement once again to you. If you just have a look, hydrogen has how many electrons in its outermost shell? It has 1 electron. Whereas helium has 2 electrons, and we call this as a duplet. So is this statement clear to you? Each element in the period will start with one electron, but as we move along a period, as we move horizontally, it ends either with a duplet or it ends with an octet. Yes or no, children? Okay, for example, lithium. Lithium will have one electron in its outermost shell. Beryllium will have two electrons. Boron will have three. Carbon 4, 5, 6, 7, 8. So is this statement correct? Every element in the period, that when I say period, it means the horizontal line. It starts with one electron and it ends with an octet. So I hope this statement is clear to you. Each period begins with an element which is having one electron in the outermost shell, but by the time it ends, it will have either a duplet completed in it or it will have an octet completed in it. Clear? So this is all about periods that you have to understand. Now let us see what will be the similarity and what will be the transition you will be seeing as you move across a period. Now what is the meaning of the word period, children? We have learned period are nothing but the HP. What is HP, children? The horizontal lines are called as the period. Okay, and I had also told you period number will give you, or is directly proportional to the number of shells. If it belongs to period 1, that means it will have one shell. If it belongs to period 2, it will have two shells. If it belongs to period 5, how many shells will be there, children? Yes, you are correct. It will have 5 shells. So please remember this statement. Period number will give you the number of shells. This is an important statement that you have to remember. Okay. Now let's start with the similarity. As I told you, as I move from left to right, the number of shells remains the same. Am I clear? As we move from hydrogen, hydrogen has one shell, helium has one shell. So if they are in the same period, they have the same number of shells. Clear? So the number of shells in the period remains the same. What will be the transition, children? There will be two transitions you will be seeing. One transition is valence electron increases by 1. Okay? So, hydrogen, I just now drew the structure. How many electrons does hydrogen have, children? It has 1 electron. Helium, the atomic number is 2. So, how many electrons will it have? It will have 2 electrons. So, can you see here, children? The number of shells remains the same. Okay? Hydrogen has 1 shell. Helium also has 1 shell. When you come to lithium, lithium has 2 shells because it's belonging to period 2. Beryllium has 2 shells. Boron again has 2 shells. Clear? All the elements of period 2 will have 2 shells. But what is the difference here, children? What is the transition that you are seeing? Hydrogen had only 1 electron. Helium has 2 electrons. So what is happening to the number of electrons? Number of electrons is increasing by the value of 1. Okay? So the transition that you are going to see is number of electrons increases by 1. Okay? Let's have a look at lithium. Lithium has an atomic number of 3. So how many electrons? 1, 2, and here it will be 3. 3 electrons. Here 4, 1, 2, 3, 4. Here 5, 1, 2, 3, 4, 5. So can you see here, children? As you are moving from left to right, as you are moving across a period, what remains the same, children? The number of shell remains the same. Okay? The number of shells will not change. Remember, period number will give you the number of shells. What will be the transition? What will be the change that you will be getting? The number of valence electron increases by 1. Okay? And there is slowly a transition. You have a look at lithium and beryllium, children. These are metallic. When I move from left to right, can you see? Lithium, beryllium, metallic, boron is a metalloid. From carbon, can you see here, children? Carbon is a non-metal. Nitrogen is a non-metal. Oxygen is a non-metal. So can you see? As I'm moving from left to right, what happens to the metallic character? Metallic character is slowly decreasing and they are now becoming non-metallic. Okay, so till here I hope it's clear to you. Okay, so what is a period, children? A period is nothing but HP. What is HP? Horizontal lines in the periodic table are called as periods. How many periods do we have? We have 1, 2, 3, 4, 5, 6, 7 periods. And we know the moment I say the period number, you will get to know the number of shells that are there in that particular period. Next thing that you have to understand here is what is similar in a period, children. The number of shells remains the same. As you move from left to right, there will be no change in the number of shells. Then what will be changing? The number of valence electrons. The number of electrons that are getting added to the shell increases by the value 1. And as you are moving from left to right, there is a slow transition from metallic to non-metallic, clear? So metals, sodium is a metal, magnesium is a metal, aluminium is a metal. But as I'm moving from left to right, slowly you're getting phosphorus, sulfur, chlorine, argon. So what has started happening, children? The non-metallic character has now started increasing. Clear? Next, we are going on to groups. What are groups, children? The vertical lines in the periodic table. Can you see the vertical lines here, children? The vertical lines are called as groups. Clear? Now again, you can see here how many groups are there. This is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Okay? So these vertical lines are called as groups. Okay? Now please remember the relationship. Group number will give you the number of valence electron. What is the short form you have to remember, children? So please remember, for periods, period number is directly proportional to the number of shells. But when I tell about group, the moment I tell you it belongs to group 1. For example, if I say hydrogen belongs to group 1, how many valence electron does hydrogen have? It will have only 1 electron. Lithium has an atomic number of 3. What will be the electronic configuration, children? 2, 1. Sodium 11, 2, 8, 1. 2 plus 8 is 10, plus 1 is 11. Potassium is 19, 2, 8, 8, 1. So can you see here, children? Hydrogen has how many valence electron? 1. Lithium has how many 1 electron? 1. Sodium again has 1 electron in its outermost shell. Potassium also has 1 electron. If you go for rubidium, cesium, francium, all will have 1 electron in their outermost shell. So what is the short form you need to remember, children? Group number will give you or is directly proportional to the number of valence electrons. For example, if I say an element belongs to group 2, how many electrons will be there? We know beryllium has an atomic number of 4, 2, 2. Magnesium is 12, 2, 8, 2. Calcium is 20, 2, 8, 8, 2. So can you see here, in all the cases, how many outermost electrons are there in the shell, children? It will be 2. So when I say group 1, it has 2 electrons. Group 2 will have how many valence electrons? Outermost electrons in it. It will have 2 valence electrons. And please do remember how many vertical lines like this are there in a group. We have 18 groups. This is group number 1. This is group number 2. This is group number 3, group number 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is also called as group 3A, 14 or it's called as 4A, 15 or 5A, 16 or 6A, 17 or 7A, and group 18, or we also call it as group 8A. Clear? So I hope groups is clear to you. So for example, if I say an element belongs to group 70, okay, what is the other name for group 70? We know it is group 7A. Okay, now look at the elements that are there in group 7, children. Fluorine, Cl is chlorine, Br is bromine, I is iodine, At is astatine. Now this is a radioactive element, children. Which one? Astatine. So it has not been that properly studied, but the scientists are guessing that it is also a halogen. Now can you see here, children? in all the elements, fluorine, chlorine, bromine, iodine, okay, how many valence electrons are there? What's the meaning of the word valence electron, children? How many outermost electrons are there? 1, 2, 3, 4, 5, 6, 7. So fluorine has 7 valence electron. Is it matching the group number? So group number is directly proportional to the number of electrons. Clear? For example, let us look at chlorine. 1, 2, 3, 4, 5, 6, 7. So all the elements in the same group will have 7 electrons. Can you tell me iodine will have how many? 7. Bromine will have how many outermost electrons? 7. Acetine also has 7 electrons in its outermost shell. Clear, children? So this is all about the revision of periodic table which you have done in your previous grade, that is grade 9. Okay. Now our actual chapter would start from the next lecture. That is where we will be discussing the periodic properties which very frequently comes for your exam. Clear, children? So please be thorough with the concept, because in the next class we will be dealing with a new atomic trend. We will be seeing the properties of a particular group or a particular period, and we will be discussing that in detail. So please stay tuned, please keep learning, please keep revising, and please do not forget to subscribe our channel for the latest updates. Thank you, children.